All right, so practice problem number 2. It says 2 boats are anchored in the harbor, separated by a horizontal distance of 20 meters. The boats bob up and down as waves enter the harbor. When one boat is at its highest point, the other boat is at its highest point, and there is one wave trough between them. All right, everybody, you know the drill. Where is this boat at? Is it at A, B, C, D, E, F, or G? Again, when one boat is at its highest point, the other boat is at its highest point, and there is one wave trough between them. Pause the video now if you need to. All right, let's see where that boat is. It's at letter B. Yeah, so we can see they're both at the highest point at the same time, and there is one wave trough between them, just one. So B has to be our answer. If you can add your boat to that location now so that you know where we are measuring from, that would be great for the next part of the problem. So we've got our 2 boats on crests that are right next to each other. And here's the rest of this scenario. So it says we got 2 boats are anchored in the harbor, separated by a horizontal distance of 20 meters. The boats bob up and down as waves enter the harbor. Each boat makes exactly 5 complete up and down cycles every 25 seconds. The vertical distance between a boat's highest and lowest position is 2.8 meters. Use at least 2 sig figs in your answer. All right, so we've got our boats, and the first thing I'm going to do is I'm actually going to go back and underline anything important in my sentences. Because honestly, word problems, there's a lot going on there. It's easy to get lost in what we're focusing on. So I'm going to go back through, and I'm going to highlight the horizontal distance of 20 meters, because I know 20 meters is important, and it tells me what those 20 meters are. Then I'm going to underline 5 complete up and down cycles every 25 seconds. Those are numbers. It tells me what they are. Those are important. And the last one we're going to underline is the highest and lowest position is 2.8 meters. So now I've got all my numbers and their descriptions underlined. I know those are the things I have to focus on to find my answers. The first question we're going to be answering is wavelength. Remember, wavelength is a length. We're going to be going sideways. So we're going to use this first underlined thing we have here, the horizontal distance of 20 meters between our boats. So I'm going to add that to my drawing. It's going to make it easier for me to visualize it. So I'm going to draw a line connecting my boats. We got one boat to the other, and I'm going to label that 20 meters. So because these are going from one crest to the other, this is actually a full wavelength. I don't have to do any math here. That's just what my wavelength is, right? If we go from crest to crest, that gives me one full wavelength. I've got half a crest, a full trough, and another half of the crest. So now we'll go to period. And in this particular case, the period, if we go back up to our equation, is time divided by cycles. So I look at the stuff I underlined. I can see 25 seconds is my time. It ends in seconds. That way I know it's my time. And then I need to figure out how many cycles. And I can read that right here, 5 complete up and down cycles. So I'm going to take my time and divide it by cycles. 25 seconds divided by 5 cycles, which should calculate out to 5 seconds. That's right. Great job, everybody. So 5 seconds is the period for this particular wave. That means we have one wave going by every 5 seconds. Next thing we're going to do is calculate speed. Again, you can use that other equation, or you can use the one we have at the top of the screen here, which is wavelength divided by period. This is just the easiest one to use right now because I already have wavelength and I already have period. So I'm going to take that wavelength, 20 meters, and I'm going to divide it by 5 seconds. So wavelength divided by period. And 20 divided by 5 is 4 meters per second. Don't forget these units. Speed is always going to be a unit of distance divided by time. So we've got 4 meters per second. Next up is our frequency. Frequency is up here. We've got cycles divided by time. I already know my cycles. It's 5 complete up and down cycles every 25 seconds. So I'm going to have 5 cycles divided by 25 seconds. And if I plug that in my calculator, I'm going to get the decimal point of 0.20 hertz is correct. Hertz is our frequency. Hertz, don't it? Yeah, just kidding, everybody. You can't get away from the jokes. All right, our last one we're going to do is our amplitude. This is where we use our final number we haven't used yet, which is the highest and lowest position is 2.8 meters. So it's not saying the distance between my boats, but it is saying the distance between my crest and my trough. So I've got 2.8 meters between the tallest point and the shortest point. But keep in mind, our amplitude is not that full distance. Again, it has to be half of that distance because it's the resting position to the tallest point or the shortest point. So if it's half the distance between the crest and the trough, I'm going to take that 2.8 and divide it by 2 to get an answer of 1.4 meters. And those are our 2 practice questions. Feel free to slow down the video, go back to any of the pieces that you need to help you out as you do your practice problems. As you work on this is your assignment to do, and then you have that second page to do as well. Don't forget to HILD. Highlight or underline those numbers, identify your variables, label your drawings, and double check your answers. Don't forget the answer keys are online. So go to those answer checks, plug in your answers, make sure that you have the right answers. Guarantee yourself a great score. And I recommend checking them after each scenario. So do the first scenario on the back, then go check your answers. Then do the second scenario, go back and check your answers. Anything you don't finish becomes homework, but really, I'm going to collect all your packets by the end of class. Just make sure they get into the turn-in bin. This should ideally take you anywhere from 20 to 30 minutes to finish that back page. If you move faster, great. If you move slower, that's fine. Just make sure you're working and do your best, everybody. I appreciate your hard work and good luck with finishing this wonderful assignment. Have a wonderful day.